Okay, here's our last big relationship, temperature volume. So again, let's review, let's think about it. If we increase the temperature, and we're going to keep the pressure constant, okay, so we're not going to change the pressure, the only thing the volume can do is increase. So if we took, let's say, an aerosol can, put it in a campfire, which I don't recommend, the volume is going to increase, but the can's going to actually explode, and that'll be a mess. So anyhow, think of it that way. Temperature goes up, more kinetic energy, more particles hitting the sides of the container, but because we're keeping pressure constant, our volume's going to increase. Again, because we're dealing with temperature, you have to take your degrees Celsius, add 273 to it to get your temperature in Kelvin. We don't want any negative numbers or zeros when we're talking about temperature. Okay, hopefully at this point you've already done 2 complete worksheets with the pressure volume and the pressure temperature relationships. So I'm going to up the difficulty on this one. This is a serious challenge problem. So what is the initial temperature of a 250 milliliter flask that is warmed to 50 degrees Celsius and the plunger rises from 0 cc's to 10 cc's? Wow, a lot of stuff packed in here. So first of all, let's look at what's a cc. I hope that you would remember cc stands for cubic centimeter or centimeter cubed. I also hope that you remember that centimeter cubed is a volume measurement and it is directly equal to a milliliter. Okay, so we could basically say 0 milliliters to 10 milliliters. So that was the first challenge that you had to get over and remember all of those 3 that are equal. cc's, cubic centimeters, and milliliters. The next thing, what does this mean? There's a 250 milliliter flask and we're heating it up and there's some plunger in the flask. Well, let's kind of draw a picture of this, and don't mind my lovely drawing here. So here's my 250 milliliter flask. So that's exactly 250 milliliters. Remember, gases take the volume of their container. And then in it, we're going to assume there's some sort of syringe probably stuck in there through a stopper or something like that. And then, if you've ever seen a syringe before, there's a plunger inside of it that looks something like this. That's closed off there. Not bad. So we're saying that we have a 250 milliliter flask, and we're saying that a plunger goes from essentially 0 cc's up to 10 cc's. Alright, so we have our plunger in there, our syringe stuck into a stopper. So now we can decide what's happening. So we have a flask that is warmed. So what does that mean? Temperature went up. Temperature went up. We already know what happened to the volume. 250 milliliter, the plunger rises, so the volume went up. So that's kind of what we know. I'm going to put that in parentheses, and you'll see why momentarily. So let's write out our initial and final conditions. So we started with 250 milliliter flask. Okay, that is warmed to 50 degrees Celsius. So what don't we know? We don't know our first temperature. Our second volume, we have 250 milliliters plus, so 250 all filled up, plus this 10. So we're going to say our second volume is 260 milliliters. And our second temperature, they said it was warmed to 50 degrees Celsius. By now you should have lots of practice converting to Kelvin, so we're just going to say that's 323 Kelvin. Okay, here's where the fun comes in. We're going to start with what we're looking for. So we're going to start with that 323 Kelvin. But we have to think. Do we want 323 to increase or decrease? Some of you are like, well, we want the temperature to go up. Well, that's true, but if we want the temperature to increase, what does this initial temperature have to be? That initial temperature has to be less than or lower than 323. So we're going to take our 323 and we're going to actually multiply it by 250 milliliters over the 260 milliliters. I'll take a moment to process that information, and we get approximately 311 Kelvin. But wait! That's in Kelvin. They gave us a temperature in degrees Celsius. So at this point, what you would want to do is convert it to degrees Celsius. So instead of adding 273, we're going to subtract 273, and that's going to give us our final answer at approximately 38 degrees Celsius. Now, does that make sense? Okay, so we started at 38, we ended at 50. Did our temperature actually increase? It did. So, there we go. If you made it through that, you can make it through any gas laws. If you didn't make it through that, that's okay. We have a lot more to practice. Speaking of practice, let's take a moment to take out your temperature pressure or temperature volume relationship worksheet, and let's work through one of those. Okay, our first temperature volume question says the temperature of a gas is 0 degrees Celsius and the temperature is changed so the gas volume doubles. So was the temperature increased or decreased, and what's the new temperature? Assume the pressure does not change. So let's write down what we know. So the temperature of a gas is 0 degrees Celsius. So temperature 1, 0 degrees Celsius. We're going to add 273, and let's make that 273 Kelvin. And it says the gas volume doubles. So at this point, it doesn't matter. Use some numbers, use some units, make sure they're the same. So let's just say we go from 1 milliliter, and our second volume is 2 milliliters because, well, that's double. You could use 10 and 20, you can use 2 and 4, whatever numbers make you happy. But make sure your temperature is 273. So temperature 2 is what we're looking for. Well, what happened to our volume? Our volume increased. If our volume increased, our temperature increased. So we're going to take our 273 Kelvin and we're going to multiply it by something that's going to make it bigger, so I would say 2 to 1. And you're going to get 546 Kelvin. Again, they started you out with degrees Celsius, so let's just convert it back to degrees Celsius. And oh boy, we're going to subtract 273 Kelvin to get our degrees Celsius. So that means our temperature went from 0 degrees Celsius to 273 degrees Celsius. That's a fun one to put your mind around also. Alright, a few more successful gas law problems, and keep working on them.